Imagine dropping solid steel into a clear liquid, only to watch it instantly boil and vanish into vapor. These highly reactive fluids can eat through iron, strip the color out of solid materials, and trigger chemical chain reactions that look more like explosions than simple changes. To understand the shock of this discovery, we have to look back over 1,000 years. At that time, the only liquids known to scholars were ordinary and predictable, things like rainwater, olive oil, and fruit juices. To an ancient philosopher, watching a seemingly harmless fluid devour a chunk of solid ore appeared to be a violation of the natural order, a display of mystical power. Yet this destructive process represented the precise moment that chemistry emerged as a physical science. The pioneer behind this transition was an 8th century scholar named Jabir ibn Hayyan. Jabir insisted that understanding nature required moving away from abstract theories and into the physical laboratory. He began by designing and building specialized glass and ceramic equipment specifically for heating and distilling raw materials. He tested various minerals and salts, subjecting them to strictly controlled heat to see how they'd react and separate. By isolating these vapors and liquids, he produced the first strong mineral acids, specifically nitric, hydrochloric, and early sulfuric acid. Isolating these concentrated chemicals broke the ancient limitations of metallurgy and opened up new ways to manipulate matter itself. While the acids themselves were powerful, Jabir's actual breakthrough lay in the system he used to find them. He documented every experiment in detail, recording the exact conditions required for these dramatic reactions to take place. He refined his techniques until he could prove that separating these substances followed predictable, mechanical rules. Jabir demonstrated that matter could be transformed repeatedly and reliably if the variables were strictly controlled. This reliance on systematic observation and repeatable experimentation is what turned alchemy into the modern scientific discipline of chemistry. The ability to dissolve metals gave early industry a powerful new capability. Craftsmen could now purify metals and extract valuable materials with much higher precision. These techniques quickly spread into the early manufacturing of medicines, as well as the creation of vibrant dyes and pigments. Over the next millennium, scientists scaled these early lab techniques into massive global industrial operations. Today, strong acids are produced by the ton to create agricultural fertilizers and to strip impurities out of crude oil during petroleum refining. They remain essential in manufacturing pharmaceuticals and storing electrical energy inside the batteries that power modern electronics. By learning to control these highly destructive liquids, humanity created an indispensable support system for modern life. The philosophical legacy of Jabir ibn Hayyan reaches far beyond the factory floor. His work proved that the physical matter of our world can be rearranged through controlled chemical reactions. He established that progress relies on evidence, observation, and the willingness to test a theory against physical results. By mastering the systematic destruction of metals, Jabir established the experimental framework that allows us to understand the chemical world today.